everyone. Welcome to my first official live stream with the Rive YouTube channel. This is a creative session, and my paranoia, I'm just going to double check and make sure that I am actually live. And yeah, it appears that I am. So cool. So in this video, there's going to be a few things that we do. The main thing that we will cover is how to add Rive, so Rive animation, to a Flutter Flame game. And instead of just looking at me, I think it would be better if I just present my screen. Give me a moment. So yeah, this is essentially what we will be making in this video. Not the full game, but don't worry about that. There's actually excellent resources to get up to the point where I will start off in this video. But yeah, the purpose of this video is a few things. The first is obviously to add Rive to your Flame game. But a secondary purpose is also to think about the way that you would approach a new code base that you've maybe never seen before. And the reason I'm saying that is because I'll give you some insight to my experience adding a Rive animation to this game. And the fact that it was quite easy to do and the way that I approached it. And that way maybe not be the best way. I'll also give probably the better way that you should approach building any new project. But I want to showcase that it doesn't need to be hard to dive into code. And also that you don't need to technically understand everything that's going on to be able to create something cool and to customize something. I personally have not looked deep into the code base for this particular game. I just took it as a jumping off point and then extended it to add this extra character, Robo Dude, on the right here. So let's do a quick demo of the game. And this is a clone of an old game, Dash game, or not a Doodle something, but yeah, this is called Doodle Dash, and the Flutter team actually made this game. And in this example here, the Rive animation is interactive. So I'm just going to cheat a bit. You can see I'm actually jumping with a cheat code that's activated, so I can just jump whenever. But as you can see, depending on like the power-ups you get, different animations are playing. So if we get this power-up over here, you can see the blades are spinning. And I have to give a shout out to Michael from Rive, who made Robodude, the awesome animation. We will explore the animation a bit more, but this video isn't all about the building this character. It's instead about implementing it in with code. And yeah, you would have seen I just missed, there was like a rocket, but here we got a rocket. Awesome. So this is my favorite animation, and yeah, this is essentially what we will be building in this video, or at least I hope so. So yeah, I'm gonna exit this, and as you can see, here is the Rive animation, and we're gonna be taking a look at least the animate tab, because we will need to know as developers what the animations are that we have at our disposal. And we'll also need to know the inputs that we can trigger. But we'll touch on this in a bit. To begin with, obviously need to give a shout out to the Flame game engine. We wouldn't have this video if we couldn't make something with the Flame engine. And then also bigger shout out to the original creators of the Doodle Dash game. So the Flutter team made this version. As you can see, they have created a whole series, a code lab, to guide you step by step on how to build your first Flame game in Flutter. So definitely that may be the video for you if you are completely new to coding and if you're completely new to Flame and Flutter. But as I said, this was the first time that I used Flame, and you can kind of hack it and just brute force your way through it and create something cool. So that's the approach that we will take in this video, and maybe you'll find that that works for you as well. But yeah, if you want more info, check out, they've also made videos. So there's a full tutorial series on building this game from scratch. Something else I quickly want to shout out is Craig, I might say his name wrong, Craig Oda, he made a few videos on Rive and Flame as well. And this was actually me working at Rive. This was the first video that I used as a resource point to just see how you implement Rive and Flame, because Flame actually has I want to say first-class support for Rive. And if we take a look at the docs and do a quick search for Rive, you will see that they have a dedicated Rive package. So bridge packages, Flame and Rive. So this is, Flame and Rive. You'll see, you can also look at their documentation for some additional examples. Let me just see if there are comments. Okay, comments are working as well. Yeah, please feel free to comment if there's anyone watching live, and I'll occasionally glance over to that side of the screen and see if I can answer your questions. So to get on with the actual coding part, we're going to start from scratch. So we know that the Flutter team has made this game. We want to extend it with our Rive animation. So let's begin at the first step, and that will be to actually just get the code base. So I'm going to go to the Flutter Code Labs, and we'll need to clone this entire repository if we want to actually access the files. So simple git clone. I guess I could have done that beforehand, but it should be done soon. Awesome. I'm going to open this folder here. And if you look at this, there's a lot of examples. Flame building doodle dash. We want this finished game. I'm just going to drag this in. You know, let's copy it in case I need to reference it later. I already have a final version. That was the version that I showed you at the beginning of this live stream. And I'm going to use that as just like a reference to make sure that I don't forget anything. That's to the right on a different monitor. And yeah, we're going to start off by opening this in our editor. So if we take a look, you can see we are in the correct folder. And I'm just going to open Visual Studio Code and open the finish game. Cool. And then the first thing we can do is run flutter pop get. Depending on the editor you use, a lot of this will probably be automated for you, but let's do everything from start to finish and nothing is hidden. I'm just going to say flutter pop get. So what this is doing is getting all of the packages that are required to run this game. And I should say, technically it is a game, but yeah, app as well. Okay, so now technically, if we say flutter run -d macOS, what this does, it's running the application and we're specifying the device to be macOS. If you are on Windows, you can also run this on Windows, and this game should work fine on Chrome as well, or Safari. So yeah, the first thing I guess that we'll do is just double check and make sure the game is actually working. So the base game that the Flutter team made. And yeah, after that, we can try to extend it. Also note, it's taking a while to build the first time. It shouldn't take as long to build subsequent times. It just needs a little bit more building in the initial build. So cool, we can choose Dash or Sparky. Let's do Dash, and the base game is working. Awesome. So step one is done. We are able to get their example working. The next step will obviously be, we're lazy. We're not going to look at the tutorials. We're not going to read the documentation. We're just going to, dive right into it and just see what's going on here. And if you're completely new to Flutter, this is probably maybe out of your depth, but I do think you'll be able to follow along at least the conceptual things that we're doing, especially when it comes to the integrating the Rive part. But yeah, if you're new to Flutter, this may seem like it's a lot, though it's something that you get used to for any programming language. The more you see something and the more you do it, the easier it is to navigate it. Me using a different theme than what you're used to could even impact the way that you read this. So If I do go too fast or something, please feel free to comment and say, yo, slow down. We don't know what you're saying. But yeah, I'll try my best to do a thorough job. So I am familiar with Flutter. So the first thing that I can notice that's different in this initial main.dart, and this is your entry point for a Flutter application, where you call the main function. And in my app, this looks very familiar if you've ever done Flutter development. And the thing that looks different to me is this game widget. And we can see we're passing in this game property. And we have this overlay, game menu overlay, game over overlay. Okay, so kind of makes sense. You know, I'm guessing this is the menu and this game object. If we, I'm command clicking this, so now I'm jumping to the definition. Here we have doodle dash. And if I'm doing the same command clicking it, we can see this extends a Flame game. And a general thing in game development, there's normally a game manager or some equivalent naming convention like that. So I guess this seems like this is the main entry point. So from like initial inspection, I guess that's, you know, the way that we can think about this here. Again, I don't know Flame. But the other approach, and this is actually how I initially did this, is I was like, okay, I need to add a Rive animation. Let's see what assets they have. They have images, they have game, background, okay, dash, center, PNG. Okay, let's do a search for dash center .png. Is it being added anywhere? You can see these are just build files. So it doesn't appear that it's anywhere in the code. So that's interesting. So maybe they're doing something to get the name from like a different, in a different way. So let's just search .png. And now that's too much. Yeah, no idea where to start. This is all the build things. Technically what you can do in VS Code is you can set your search to not include the build directories. But I'm not going to do that now. This is actually a new machine. So this is why I'm getting this weird results for searching that I didn't expect. But the point I'm trying to make is that you can technically just search for the assets in your file. And if you do that, and if you were to go through that list and actually find it, eventually you'll get to this player.dart class. And actually, if we just go to doodle dash as well, you can see here we are creating, or not yet, but we have this this variable called player, and it is a player class. And if we scroll down here, eventually you'll see we have this .png. So this is the place that we are loading these character sprites. Okay, so and it's doing this based on like the character's name. So that makes sense because we have dash and we have the other character, Sparky, and depending on which one you choose, it just loads the correct file, which makes sense because we have, you know, dash left, and I'm guessing there would be a Sparky left as well, if we were to find it here somewhere. Okay, so cool. We at least now have an entry point. We know that if we want to show something, maybe it makes sense for us to do it here. And yeah, bear with me, I'm actually going to do it the wrong way, and then I'll show you the right way. Because eventually we want to extend our game to be more than, you know, just a broken version of the original game. So interesting, we have this onload function. Okay, and this is like after doing a bit of research, how can I show something with Flame and Rive? Well, it's actually quite easy to do. But before we do any of that, I'm gonna remove that. And just to help us along in this process, I'm going to create a new Git repository, and I'm just gonna add everything. And the reason I'm doing that is so that we have a clean base that we can easily go back to, and so that we can also easily see the changes that we've made. So I'm just going to say this is the initial game, and I'm adding all of the files that we got. And cool. So now, if we were to, for example, do a print just a test here, and I save the file. We can see on the left source control, we've updated the player file, and this is what we've added. So this is a very nice way for us to quickly experiment, and you can do whatever you want, and eventually if you are afraid that you broke something, you can easily just revert back your changes. So this is a good starting off point to experiment. So yeah, what would be step one? For me, it would be to actually display a Rive animation in the game. It might not look great, it might not be correct, but let's just do that as a first step. So the first thing that we'll do is in the assets folder, we're going to create a new folder, and I'm going to call this Rive. Let's try that again. And okay, so now we have images and we have Rive. And I already downloaded RoboDude. So I'm just dragging in the Riv file. So RoboDude flutter.riv. And I got this from the Rive editor. If you just go download, this is for the newest runtime v7, and that should work. Sorry, I'm just getting messages. Okay, nothing important. Cool. Okay, so now we have the asset added. However, you also need to do that in your pubspec.yaml. So in the assets parts, you need to specify what assets to include in your application. So here we're just saying the whole Rive folder. We can specify just the single one, but this is just a shorthand way of saying everything that's in that folder included. Okay, so we can delete that. Well, not delete, we can close it. And then in onload, this is now the first place that we actually want to do something. Let me just get my reference. Okay. So we will need access to Rive. So you may be inclined to add a dependency. So this, if you don't know, Visual Studio Code allows you to do this for Flutter development. You can quickly add a dependency. So I pressed Command-Shift-P. This is the command palette, and then you search for add dependency, and I'm adding it. So you can add Rive. Why is it not? Okay, there we go, Rive. But luckily for us, the lovely people at Flame, who maintains the package, they actually have a Rive already working in Flame. So if you import flame_Rive, you are getting the Rive package and you are getting the Flame package, including some helper classes to move things along if you do Flame and Rive together. So let's see. Sorry if it's jumping around like this. My mouse is very sensitive. I don't know why. One thing we can now actually do, if we want to be thorough, is we can technically remove the Flame dependency. We just need Flame Rive. And you can see when I save it, it automatically ran Flutter pubget for me. So we should now have that dependency. And if you've ever used Rive, be it in Flutter or any other runtime, you'll be familiar with the concept of an artboard. And if you use the editor, you would also be comfortable with the concepts of an artboard, because the artboard is basically everything you see on screen over here. And it's not loading for me. Let's try that again. So yeah, the artboard is this over here. And you can actually add multiple artboards to a Flutter, not Flutter, to a Rive file. And you can load the artboard that you want. In this instance, the artboard name is robot. And we only have one artboard. So this concept is coming from Rive. And as you can see, I just press command period, command dot, and I'm adding the Flame Rive package. And I'm just going to say this is a test artboard. And what you need to do is, this is a function that is now coming from the Flame Rive package. So you can see it's from Flame Rive source Rive component. And this Rive component is something that is specific to Flame. So that doesn't actually have anything to do with Rive. It's just a cool way that you can easily use Rive in Flame. So the artboard that we want to load is, if we look at what we need to give it, we need to give it a Rive file. Okay, so cool, we'll say Rive file, and this is an asset. Can be anything. It can be a network URL as well, or binary data. And we'll say assets, Rive, and then finally the name, which is robodude underscore flutter dot rev. Cool. And let me just check and see if there are any comments. Okay. Okay, so Jeff is saying, I have no idea what you're saying, but slowing down won't help me. Just enjoying seeing what's possible. That's awesome. That is how I feel when the designers speak about them creating the designs. I'm like, wow, it's so fancy that they can create these things, but no idea what they're saying when they use some of the more advanced things. You sound South African. I 100% am. Proudly South African. Currently living in the Netherlands. And we got an interesting, cool. I hope so. And then, yeah, Zach said, so cool this integration exists with Flame. I definitely agree. After speaking to Guido, the CEO of Rive, he said Flame team actually, like, for a long time has had like first-class support for Rive and Flare back in the day. So before Rive was called Rive, when it was Flare, they also supported it back then. So it's really awesome. Okay, continuing the coding series. The next thing that we'll want to do, normally for Rive, when in Flutter, when you want to show an animation, there's a few ways you can do it, and we'll actually do that in a bit. We're going to do the Flame way now. So for Flame, you would need to have a component, and that component needs to be added to the game scene. Maybe I'm using the incorrect vocabulary, but yeah, bear with me. So we'll call this robodude. There's a Rive component, and then again, this is coming from Flame. We pass in our artboard, and that should be that. But we'll do a few extra things. We'll set the size for robodude, and this will be vector2, and instead of giving the x and y, you can say .all, and we'll say it's 200, and robodude position as well, and we'll say that this is vector2, and what's it called, 0. And finally, you can call add, not as, add robodude. And if we hover over this, you can see that schedules a component to be added as a child to this component. Okay, interesting. So what this is doing is adding this Rive component as a child to this. So if you are familiar with the concept of this in programming, it will refer to the current active instance. And this is, my scroll wheel is annoying me. This is a sprite group component or player. Okay, so we'll actually see exactly that makes sense actually. So I'm just gonna run that's the Mac OS. So it should work, hopefully, and we'll actually have an animation if I didn't do anything wrong. Okay, so we still have our base characters. If I select dash and start, okay, cool, interesting. So it's adding our Rive animation. It's not playing anything. It's just loading the file and like the first scene or the first artboard and I guess the default animation or the first animation. This instance, no animation. And it's adding it to follow dash. And that makes sense because if we read what this command said, or this function said, it says it adds it as a child to this component. Okay, so we're getting somewhere. We have our POC, Rive is working. The people at Flame didn't lie. You can you can do it. How do we do this in a clean way now? How do we actually go the next step and create more, basically so that it works with Rive and it works with the normal sprites approach as well, so that we can have 3 characters. And for that, we'll need to go an additional step further. So I'm going to remove this, and we don't need that anymore. And let's just close everything. And cool, Craig is saying, hoo-hoo, I'm too living in UK now. That's awesome. I'm guessing you probably miss having Brise as well. I'm not sure how often that's possible in the UK with UK weather. Here it rains a lot, but that's off topic. So to continue, we have, if we go back to main, you can see we have our game widget and this overlay builder, and we have our main menu overlay. So let's do that as our next step. We want to actually add an additional character option. So if we scroll down, this is just like normal Flutter code. You can see we have row, character button. And if we just run the application, that will help us to visualize what's going on in our screen. So it's this character button, and you can see we're passing in character dash and character Sparky. So the naive approach, it's going to be, let's just add another one. And just okay, so now we have 2 Sparkies, but we don't want Sparky. We want, let me use my different keyboard. We want RoboDude, but we don't have RoboDude defined. So let's see what this character is. It's an enum. Let's jump to it. And, again, very naively just add RoboDude. That's what we want in our game. So save that. And is it working? Okay, it is technically working, but the thing is now we'll need to actually do it for all of these. So you can see when we select something, it's setting the selected value of the character. And there's this onSelect character, which is called setState and sets the character as well. So we'll basically need to do it for this whole section over here to make sure that the correct character is selected. And I do believe now it's actually going to break. And cool, it is breaking. You can see unable to load asset something. And if we inspect this source code, or not the source code, the error, you'll see that eventually my gosh, it's giving so much. Okay, yeah. Like if you read this and follow it through, you'll see that, okay, it's actually giving an error because like that image isn't defined. So when we are showing that character, it's not finding the image. And that makes sense because we don't have a RoboDude image. So, okay, so the next step was at the bottom. Yeah, RoboDude sensor.png. It doesn't exist. Cool. So, fine. Let's go into character button and do a bit of customization. We can see that in this widget, we are displaying an image, and it's as we saw before, depending on the character name, it shows the sensor image. Okay, so we're just gonna hack it a little bit, and we're gonna say if the character equals character.robodude, then we will do a different value. So this is just a shorthand way for you to, oh, actually this is wrong. Yeah, I'm just gonna select this and delete everything. Sorry, I wanted to add it at the top. So here we're doing a column and we're displaying these 3 widgets. So we want to display different widgets if the condition is that the character is a RoboDude. So I'm just gonna have it be an empty array for now, or an empty list. And I don't think we need the if. Okay, so now technically it's not going to display anything, but let's just say we'll just display the text with the character name, and we'll do a restart. Okay, so now we have RoboDude, but now we need to display the Rive animation. And if you've used Flutter and Rive in the past, you'll see that this is actually quite easy to do. So we'll say Rive animation, and this is an asset, and let me just put a comma there. Okay, the asset name is going to be assets Rive, yeah, and then RoboDude underscore Flutter dot Rive. I wish it had a different name. It's a lot long now. Okay, so reload. Okay, unimplemented handling of missing static targets. Interesting. I didn't expect that. Let's do a hot restart. Okay, so different error. You can see there's a lot of render flex object was given an infinite size during layout, and you can see like the characters in a space that doesn't make sense. And the reason for that is this is a Flutter thing. It's because we are in this column layout, and we're basically giving our Rive animation an infinite size. It doesn't know how big it should be in the context of the column. And there are other ways you can do it. You can see in this image, we are specifying a character width and a character height for the image. So what we're going to do for the Rive animation is the artboard of a Rive animation will be the size of that the parent allows it to be. So depending on like the available width that you give it, you can take up all the space if needed. So I'm just going to wrap this in a new widget, and there's going to be a sized box and trailing comma. And what we'll do is give a width, and the width is going to be character width, and height will be the character width as well, because we want it to be square. And if we hot reload now, cool, RoboDude is working. I think actually, okay, no, it didn't do an animation, but we're getting somewhere. Okay, we have our RoboDude, and it's semi-possible to select him. And you can select him, but it's going to break the next stage. I do want to do one thing though. You can see that it's not taking up like a lot of the screen, and here it's going to be dependent on like what you're doing in Flutter and like how things are laid out. In this instance, you have a few options. What you can do is you can give a fit for your animation. So for example, you can do contain, which will contain the animation to the size, cover, which will like take all the available size. And as you can see with cover, it's taking all the size, but the problem is that this widget is doing some clipping as well. So this circle is clipping the animation, and that's not what we want. A quick little hack in this instance, and this is what I did, is to wrap your Rive animation in a new widget and transform scale, give it a scale 1.3, and we're just saying make it a little bit bigger. So don't worry about like sizing and stuff. I promise you there's enough space. And here we have an issue. You can see that the original app wasn't designed to be this small, but we're not going to care about that for now. That's trying to get the beta game out. That's a final release thing we'll do. Cool, so RoboDude looks cool, and we can select him, and if we click start, nothing. Interesting. So if we take a look, you can see we have this player on load, doodle dash sprites, load character sprites, and okay, that's interesting. So the problem seems to be that, we're not loading the correct character sprites, which makes sense because it's a Rive animation. We don't have character sprites for this. So a good place to do this, or like if you want to debug something, you can just easily command click and then, or control click, I guess, and follow it. Okay. And like I said, the problem is that we're trying to load sprites that don't exist for the character, and that's why nothing is being displayed. And this will be the next step now. It's how do we do this to show a Rive animation instead of the sprites? And the initial approach that I took, and I'm not going to show it here, is I just did like some logic here to test, you know, if the character, you know, is if character.name equals character.robodude, you know, I just did something else. I just loaded in our Rive artboard as I demoed for you earlier at the start of this video. But that's not the cleanest way to do it, and I definitely don't think that's the Flame way to do it. The reason for that is because doing that approach, you would essentially be creating a Rive component. And instead of creating it like that, you can instead extend the Rive component class and then create it in a cleaner way, or more reusable way, I would say. And you can see this is what's currently happening with the sprite class as well, is we have this player that extends the sprite group component. And this makes sense, you know, we're displaying sprites. And in a similar way, what we technically want now is we want to create this Rive player that extends our Rive components. And earlier, as I said, we made our own Rive components and we added it to this one here as a child to that. But now we want it to be conditional. We either want the Rive player to show or we want the original player to show. And this is now the next step, and I'll also show you the cleaner way to make sure that we do it the correct way from the start. Let me just see what comments there are. Okay, I'm sorry if I'm saying your name incorrectly. I'm Akash. I'm just, yeah. Lol Sparky is the character from Clash Royale game. Interesting. I did not know it. I think I may be wrong. I was under the impression Sparky was for Firebase. You know, Google products, it makes sense that they have Dash and Sparky. So I may be wrong on that, or maybe it's both. And yeah, hello to you too, Rexford. Thanks for tuning in. So yeah, let's continue before I completely forget what I have to do. Okay, so we have Rive player, Rive components, and it's giving us an error. It's saying that the superclass Rive component doesn't have a 0 argument constructor. You know, okay, so it needs a constructor, and you know, lazy approach, create constructor to call super. I just press command period, and this will, you know, auto create it for us. And what the Rive component needs is it needs an artboard. So whenever you want to initialize Rive player, you need to give it an artboard, and artboard is coming from Rive. So awesome that that we can do. We've seen how to do that. But before we delve into like doing this, let's actually just see where we're using this player class. So I'm right clicking this and I'm saying go to references. And you can see we have 2 references. Here where it's created in player or defined in player.dart, and then also where it's initialized in doodle dash. And if you remember, the doodle dash is this file over here, or this class, is our main Flame game. Doodle dash extends Flame game. And here we have this player field. Okay, so interesting. At some point, we are setting the player to be something. And if I'm just searching for this, let's see where we're using this. Okay, we can see player is moving down. Follow component, so the camera follows the player. Here we're doing something with sizing. It's a condition to lose, I guess. We're resetting the player, resetting the position. Okay, here we're initializing the player, and we're also adding the player. So here we're adding, again, that's that component thing. We're saying add this component to the Flame game, or to the current instance, I guess. Okay, interesting. So here we have our sprite player, but we want to conditionally have it be a Rive player. So the first thing that I'm going to do is I'm just going to make it less confusing for myself, and I'm just going to call this a sprite player. because that's what it is. And now we can do some conditional logic. We're going to say if the game manager.character equals character.robodude, then we want to set the player. So let's just make a comment, set player equal to Rive player. Else we'll do this. Okay, why did I do a comment? Why didn't I just do it? Well, this is where we'll run into an issue, is if we try and set player to Rive player, and that won't be possible because Rive player is not the correct type. Rive player is a Rive component, and sprite player is a sprite group component, while Rive player is the Rive component. Okay, so now we have a choice. We can either conditionally have logic where we say, okay, well, we can't have a player be either sprites or Rive, but we can maybe do this. Maybe we should do Rive player and then conditionally set Rive player or player. But the problem is that this will make a lot of work for ourselves, because now every time when we use player, like player is moving down, player position, you know, player reset, we'll have to do the same thing, kind of. We'll need to do player reset position as well. It seems like we're duplicating a lot of work. So this is going to be, you know, the shortcut approach. I've already gone through this, and I know what we should do. So the best way for us to do this is to use inheritance. And we've seen that we want some base class that we can extend or implement that will have all of that functionality for us. So just as like this Rive player extends a Rive component and sprite player extends a sprite group component, if we look at what this class is, you can see it's a position component. Okay. And if we look at this, we can see it's also a position component. So cool. Well, that means let's rather do a class called player, and we'll extend a position component. And let me just spell that correctly. And now what we'll do is we'll implement player, and we'll do this mouse, and we'll do the exact same again. So we'll implement player. Okay, so now that means we can, you may even like ask why am I doing this? Why not just use position component directly? And the reason for that is because we'll need to add some additional methods to this to make it optimal or clean. So okay, both are implementing player. So that means that if we now go to the place that we actually used it, let me just close some files. So in Doodle Dash, here where we're setting the player, it's no longer a sprite player. We want it to be the parent player. Okay, so now we'll be able to do the following. Where we set player equals to Rive player, this would work. So player equals Rive player. And awesome. Now we just need an artboard. And to do that, I'm going to do that at the top here. So I'm just going to say, I guess, late artboard. And artboard is coming in from Flame Rive. So I'm just going to import that. And then in this onload function, we can just load our artboard. So artboard equals artboard. Oh, actually, no. We'll need to do a bit more. Just give me a second. I'm just going to copy it in. I forgot, so we've already done this before earlier. This load output is coming in from the Rive Flame package, and this requires a Rive file. Rive file is coming from Rive package, and we're saying that it's an asset. Cool, so output is now initialized, and that means that at the bottom here where we pass in the output, it's now no longer giving an issue. But unfortunately, we have more issues now. You know, player.resets is not defined, reset position is not defined. set jump speed is not defined. And the reason for that is because all of these methods, set jump speed, for example, are currently set on the sprite player, and it's not set on this player class that we are implementing. So easy solve. We just need to go through that and like one by one add those methods. So this is where, technically if you were doing this from scratch and you only wanted to do a Rive animation, it would be a lot easier because you don't need to navigate this loopholes of, okay, I want to show sprite and Rive. So, your experience may vary in this. You don't need to do this if you only want a Rive animation, and you don't need to do this if you only want sprite sheets in your Flame game. Seeing as we want both, we'll need to do this. But yeah, that's a bit of a boring step to live code. So I'm just gonna, copy paste in the final version. This position I think is not needed. I also don't think this is needed. Okay, if it is needed, I'll add it. Okay, but either way, now we have one thing we can do is we can make this an abstract class. So what that means is that you can't implement player. So if you wanted to do player, it's going to say no, abstract classes can't be instantiated. And the reason for that is because it doesn't make sense for us to instantiate this class because these methods don't do anything. All we want to do is make sure that we are actually implementing them in the classes that are, we're extending or overriding these methods in the classes that implement player. And you can see that Rive player is now giving issues. It's missing concrete implementations of these methods. Cool, not a problem. Create six missing overrides. I just press command period. And awesome. It is now going to throw an error probably because none of these are currently implemented. Actually, it just won't do anything. Okay, cool. So Rive player is now implementing all of these. And if we look at doodle dash, okay, we do need is moving down. That's my fault. So I'm just going to add that. That's a Boolean. And that is a get, not a function. And again, we'll add the one missing override. And cool. So now we don't have any errors because all of the methods are defined. We can call them. And as well, we have this logic now to make sure that we are creating a Rive player instead of a sprite player. So just for lols, it's not going to work. Let's actually see what it looks like on screen right now. Going to do a hot restart. Okay, Sparky should work. Awesome, our sprites are still working. And RoboDude, it doesn't work. Okay, that makes sense. It shouldn't work yet because we haven't done anything to make sure it does work. Okay, but it is at least like we haven't broken like the old sprite sheets yet. And it seems that it is using the correct, it's using the correct logic that it's not trying to use Rive player. Okay, so I'm just going to quit that and let's now go the next step of implementing some of the logic to allow us to do Rive player. Okay, and again, we're going to go the lazy approach. You can see that if we look at sprite player, it's doing a lot. It's like, okay, they have this update logic. And if you're familiar with game development, there's normally an update function that you can hook into. And this gets called probably for each animation tick. And it gets this concept called delta time. Depending on that, it's the time since the previous frame or the previous game update. Also, I'm sure the Flame documentation is great, and I'm sure the tutorials that everyone made is great to actually go through and like understand how to do this game. But all we want is we want to add Rive to our animation. I don't feel like going through all this logic now, so we're gonna do the same thing. We're gonna go the cheap approach. I'm just gonna go to the bottom here and go to the top. Gonna copy it. Not delete it, copy it, and then, just remove all of this and paste it in. And we'll get a lot of errors, but don't worry, we'll fix them. The first one is that this is not the correct constructor name. So Rive player, sprite player, should be Rive player. Here we are running into issues. We'll fix this in a moment. And we also have these issues that current isn't defined. Okay, and that makes sense. GameRef is also not defined. Okay, cool. The reason some of these aren't is because we need to also add these additional mixins. So we can have with has GameRef, keyboard handler, collision callbacks. And as the name suggests, I'm guessing these are the things that they're doing. And this GameRef seems as like it's definitely something that we need because it's currently giving an error. And yeah, so we'll just add that here. Save, and that should get rid of a few errors. We can see current hasn't gotten rid of yet. Okay, so why are we still getting an issue for current? Well, if we scroll down and look at the sprite version, sprite player, you can see that we do have current over here. Yeah. So when we do onload, we set the current player state to be player state center. Okay, what is player state? If we click this, it's an enum, left, right, center, rockets, okay? So that's like the states of the animation to show. And if you take a look here, you can see that sprite group component, you know, it has, it defines that it is a player state. And what that means is we are setting the current value, so key with the current playing animation, to be equal to player state. Okay, and in the bottom here, load character sprites, you can see that we're doing something else as well. We're setting the sprite map, which is a combination of player state and the sprite to show. So this means that depending on the current state, we are showing a particular sprite. So if the state is left, we're showing the left sprite. If it's right, we're showing the right sprite. Well, we don't need this. You know, we are going to be doing an animation. We don't need sprites. And the Rive components also doesn't have access, you know, to this logic. We don't need current in R. But I did make a screw up because we do need it here. This is the sprite version. Yeah, we don't need it here. So you can see we don't need sprites. I'm going to remove this function. And current, this is actually something that maybe we need. It makes sense. You know, it seems like we're using this a lot. If we're going to remove this, we'll need to do a lot of like additional logic to make sure our Rive player works the same as the sprite player. So this seems like maybe what we want to keep it. So we're going to keep it. So what was it called? Player state. So we're going to say player state equals current, sorry. And I guess we can make this a late, or we can just initialize it, I guess. Maybe player state center, I guess. Okay, so now we have a local variable called current, and the reason we're defining it here is because Rive components doesn't have this current defined, but the sprite version does because it needs that. But it makes a lot of sense for us to keep it because depending on the player state, we want to show a different kind of animation. So awesome. What is the next step? We can see the name parameter artboard is required. Okay, so we're just going to say super.artboard. And what's this giving an issue? Okay, it can have a value of null. So that means we have to pass it in. So we're just going to make this a required field. So that means when we initialize our Rive player, we need to pass in an artboard, and we had this earlier. This is just me, you know, copying the other code that broke it. And it seems like this is going to work fine. And we don't have this method anymore. I'm going to delete it. Okay, and then doodle dash is not working anymore. And that is because we gave additional arguments. So I'm just going to copy paste what we're giving here. And again, this is where we are actually initializing our Rive player in the set character call. And if we look, we don't have any issues, no problems. Let's run our application and see if it's working. All right. Doodle Dash is doing jumps. This is something I forgot, so we should probably, I'm gonna delay the the final reveal of like it working, and I'm gonna do something quick. In our Rive animation, in the main menu overlay, what we would like to do as well is show an animation. Currently, it's just it's static. It's boring. Sorry, I forgot about that. And we'll do state machines, and we'll need to give the state machine for RoboDude. And if we take a look at the animate mode, we can see that we have a state machine. It's called state machine. Cool. So the state machine name is state machine. And now it should animate. Okay, RoboDude is animating. Sorry, forgot about that. And let's play. Oh no, why didn't it work? Let's try again. Select RoboDude. Okay, now it works. Okay, we have our Rive animation, but it's not animating. It's still a static image, unfortunately. So yeah, a little bit disappointing, but that makes sense because we haven't told it to play any animations. We just ran into this issue with the menu as well. If you don't tell it what animation to play or what state to be in, it's not going to change. So that makes sense. We need to do that. And luckily for us, most of the logic is already defined in the player class over here because we already set the current state a few times. So when this changes, we want to show a different kind of animation. Cool. So that makes sense. That means we need to extend our app to allow us to do that. And I'm going to show you how to do a few animations. And then for the rest, I'll point you to the final version of the code because then it becomes a little bit repetitive and I think you'll get the idea of how to do it. But yeah, let me just find it. Okay, so what we'll need to do is, if you're familiar with Rive, you need a controller to interact with your animations. And the type of controller that we'll need is a state machine controller. And state machine controller, we'll define it like this. And then we'll need an additional thing as well. We'll need to get the input triggers for our animation. And if we take a look at these inputs, you can see there's a variety of different inputs. So let's just play our state machine. We'll play our animation. We have idle mode, makes sense. And we have a look left, we have look right. And these are triggers. So when this is triggered, the animation will update. And you can see we have flying, we have blade spinning fast, and then we have our jetpack. And these are booleans that we can set that you can set true, and if it remains true, the animation will continue playing. While for triggers, it can be dependent on like how you as an animator sets this up. Okay, so we need access to these. Okay, so we know that, and we also need a way for us to define or to pass in our state machine controller to our artboard. Okay, so the first thing that we'll do is we're just going to create a new method. So I'm going to do it here before any of these onloads. I'm going to create something called setup_rive. And in onload, we will just call that. Why isn't it working? Oh. Okay, we'll call setup_rive, and if I can type. Oh, sorry, I forgot. Are there any comments? No. Okay, so setup_rive. This is going to be triggered on load, so it's the first thing we want to do. And we'll start off by just giving a value. So we'll say that this is the state machine name, and I'm making this a constant because it's not going to change. And this is called state machine. And just to refresh your memory, it's called state machine because it's called state machine here. If we wanted to call this something else, we can. And when you export this Rive, eventually, you know, it will have that name. But in this instance, it's called state machine. And what we'll do is we'll create a new controller, and this is going to be a state machine controller. And we will say that this is coming from an artboard. So this is just a convenient factory method for you to say, hey, make a state machine controller given this artboard and given this name. So it's using this name here, and it's using the artboard that is available on the Rive components. Very cool. Let's continue. We'll do a quick check to say that if the controller is not equal to null, so we'll just make sure it's not null, then we'll do something. Else, and this is just a little, I do recommend you do this in your code. It will help you avoid like a lot of weird errors. We don't want our game to ever run if this is wrong. Like if you are giving the wrong names to your state machines, it shouldn't be handled gracefully. Like you can probably just throw an error, not even an exception. So if you want it to be, you know, more insane, you can throw an error, but I'm not going to do that. I don't want to do that for this tutorial. We'll just throw an exception, and I'm just going to say could not load or could not find state machine named dollar state machine name. You know what? So I copy paste. Okay, so it should find it. If not, give me an exception. And if the controller is not null, then what we're going to do is we want to set this state machine controller field that we have here, because we want access to this one throughout the whole class. So state machine controller equals controller. Again, there's plenty of ways to do this. Like this is just one way to do it, so you can do it in other ways. And finally, we will go and to the artboard, we will add our controller. And if you just do normal Flutter development with Rive, this should be familiar to you. Okay, so now we have our controller defined on our artboard, but we also need a way to actually find these inputs. Okay, so to do that, we'll need to define a few extra fields. And let me just get the code. This will be an submit. So it's going to be an SMI trigger. Okay, and we'll say that this can be nullable, and we'll say that this is a look sensor trigger, and we'll do another one. Let's just actually copy paste it. So this is look left, and the final one is going to be look right. Okay, and now in our setup over here, we have added this to the artboard, the controller. And what we want to do is we also want to find these inputs. So we're going to say that the look sensor trigger is equal to the controller.find SMI. And then we need to give the name. Okay. And if we take a look here, we can see we have look sensor, look left, look right. Okay. So look sensor is going to be called look sensor. And we'll clone this and look left trigger, look right trigger, and left, right. Awesome. And again, you know, it's becoming a little bit of nested hell over here with all of these if else checks, and you can definitely separate this to be a little bit cleaner, but I think for the purposes of this tutorial, it's fine. What we want to do is make sure that these aren't null as well, because again, if they are, it just means that you know, the app shouldn't be working. And there's no reason for these to be null, because that means you gave the wrong names, or it means that the animation may have changed between design handoff and engineering handoff. So we'll be consistent and make sure that we don't have weird errors in our application. And you're like, why isn't this animation playing? When in fact you just named it wrong, and you don't want that to happen. Okay, so if they are not null, then oh, actually I lied. I wanted to do something else. We don't need to do any logic. This is just going to be equality checks. So if they are null, we'll throw an error. Otherwise, we'll continue down our happy path of not doing anything. And we'll say some Rive inputs not found. Okay. Now, technically, I would like to continue, but let's just run it and make sure that these errors aren't throwing. You know, we did the effort of putting in these exceptions, so we might as well see if we're getting any exceptions. Okay, why is it not showing? Okay, RoboDude, press start. No exceptions, but no animations yet. Okay, last step for us in this video, it's becoming a long video, is for us to actually play these animations. So we have access to these triggers. Now we just need to trigger them. Not get triggered, but trigger them. And that's really easy to do. And again, you can do it in any way that you want. I'm going to do the following. Let's create a few additional methods. I'm going to say trigger look sensor animation. And we'll call this look sensor trigger. And if it's not null, we'll just fire it. And what this is what this is doing is you're telling the Rive animation, hey, trigger this event, trigger the look sensor event, just as we're doing in the editor when we're playing the state machine. And I say look sensor, look left, it's triggering these events, okay? And they can't be set, it's not a value, you just trigger them to happen. And in a similar way, we're going to do trigger look sensor animation, or look left and look right. And I'm just going to copy that in to save some time. So yeah, these methods are the exact same. It's just triggering left and right animations. Okay, so now the question is, when do we fire this and how? And this is now dependent on the game that you're making. And it's going to be dependent here and like what the code does. As we know, we have access to this current field over here. And depending on the current value, you know, things will happen. So for example, you can see onload current player state center. I guess that makes sense for us then to call, you know, trigger look sensor animation. By default, the animation will load to look sensor, but you know, here we are ensuring that that trigger is going to fire. And we can go down this whole rabbit hole and look everywhere where we're doing stuff. Let's just do the examples for left and right. So left, we can see I just searched for left here. We have move left, move right. Let's jump to this method, move left. This is still in the player class. And the only thing that we're going to do is, I mean, either in the beginning or the end, it doesn't really matter. Or maybe it does, depending on like what you do. We're just going to say trigger look left animation. And finally, move right. We'll do the same thing, trigger look right animation. And you may ask, why am I putting it underneath this? I don't know. It probably would work right there as well. Yeah, let's put it at the start of the method. And now, finally, if we run our application, it should work, at least the left and right animations. Probably didn't hear that because I didn't say it into the mic. Let's make it bigger. And, okay, start. Okay, and you may not see it because it's really small. Let me zoom in. You can see he's looking left, looking right, looking left, and it's working. Okay. And why is he not looking back to the center? That's because we haven't defined that logic yet. All we're doing is saying in the start, look center, and then if you press left, look left. If you press right, look right. So now the game will just need to be extended, and you'll need to add additional animations. And that's where it's, you know, that's actually the fun part. All of this was just set up. Now you can actually like configure the game and do it in a way that makes it fun and interactive. One thing I'm going to show though is something that bothered me right now is the fact that the size is a little bit small. So when you initialize this component, you can make it a bigger size. So I'm just going to set it to be a size that feels better for me, or looks better to me at least. And you'll see that I'm also anchoring it to be at the bottom. I'm actually not sure if this makes a visual difference, but it's what I had in my final version. So we'll do that. And the only difference this makes is it makes the character bigger. So, I mean, now you can see he's just bigger. Okay, I'm almost done rambling, if there are still anyone watching. Let's exit this one. The final step, as I mentioned, would be the fun step. And that's where we're not going to go through that process in this video, because it's just going to be repetitive. As you can see, this is the final code. We have our player Rive. None of this has changed. And the only things that are different is the fact that we have more triggers. Here you can see we have these SMI inputs, which are Boolean values, and it's idle, flying, blade spin, and these are things you can set to true and false. And if they're true, they're animating. If they're false, they're not. Maybe it depends on the logic of the state machine. And in that way, you'll see we have a few additional animations. And here we have look center, left, right, and then play jump animation, play trampoline animation, play hat, play rocket, and play fall animation. And these are defined in a way to mix and match your animations to make sense. And this is what's really awesome about Rive is you can do it in such a way that you can play the look left animation while playing the jump animation or while playing the rocket animation. And you can see that with this animation over here. For example, when we play the hat power-up animation, we want to first play the fly animation, because the fly animation will disable the blade spin animation. Wait, is that correct? Yeah. Disable blade spin animation false. Sorry, weird logic for me. I did this a while ago. It's saying, hey, actually play the blade spin animation, and flying trigger is true as well. So it will put the character into a flying state. So as an example, we'll say flying yes, we'll say blade spin off, and this is just the naming convention of the Rive file. I could have probably gone back to Michael and said, can we rather call this blade spin on, because it's more consistent with what we have here, meaning true to do, not false to do. But okay, in this instance, we want this to be false, which we are saying blade spin trigger, disable blade spin false. And we have flying, blade spin is on. Eventually, maybe if you want to play the rockets as well, and we can look at that for the rockets animation. We play the fly animation, and we also set the jetpack trigger value to true, okay? So we play flying, and we set jetpack to true. And that's how it works. It's just a matter of setting the correct inputs and playing the correct animations for the correct states. And these methods are just convenient ways for you to clean up your code. And you can see this play rocket animation. It's being called in the this on collision. So in the on collision method, there's some checks to see if the player doesn't have a power up and the collision event is a rocket, then set the current state to player state rocket, do some additional things Jump, I think, is the velocity being applied. And then play rocket power up animation. Simple. Like, it's just a matter of like then playing around with it. And honestly, here I just experimented for a while and like looked at like all of these things and like tried to add the animations to the correct place. Yeah, this jump animation or this jump method was pre-existing. All I did is I added this play jump animation to the bottom there. And I think that's the bulk of it. It might actually be good for me to play this one more time, just so it's clear. But yeah, I don't see any additional questions. I may be alone on the stream, but I do want to say if you have questions about this, the Flame community is really open from what I've seen on Twitter. You can definitely reach out to them for questions. If you have questions about Flame, I'm probably not the person to ask. If you have Rive questions, definitely I'm the person to ask. You feel free to reach out either here on YouTube, or you can follow us on Twitter. My Twitter handle is in the name. Feel free to reach out if you have questions. There's also a Discord if you want to chat to us there, and that's probably the best place to chat with us, especially if you want to see what upcoming features there are. But yeah, this is the final version. Everything is working, and trampoline, you can see it does different things, and I'm just gonna be cheating a bit, but yeah. I think that's it that I wanted to say. The last bit is that this is definitely a process between defining what the correct inputs are for your animations and then finally determining, how you will do that in your game. It was really fun to do this with Michael at Draw Goods. You've probably seen his work if you follow Rive. Him and I, we sat in a quick meeting. We played the game, the base game. We're like, okay, what animations do they need to be? And he knocked it out of the park, creating RoboDude, and he actually just extended RoboDude and added some additional animations to him. Okay. With that said, I think we are done in this live stream. And of course, classic Rive stream, we get a question at the very end. Does Rive support AI? It depends. It depends what that means. That can be interpreted a few different ways. Are there like AI functionality built into Rive where you can like auto-generate images or auto-generate assets? The answer is no. But Rive does support both vector and raster images. So technically, if that's your question, if you can use Midjourney or some AI-generated art in your Rive animations, the answer is definitely yes. You can also do mesh deformations. I can actually do a demo. Yeah, definitely take a look at the Rive community. This is a good example. I love this. Lara made this. You follows your eyes, and it's like a forgot password thing. And if you trigger out, yeah, it does that animation. This is a combination of vector and raster graphics. So yeah, that makes sense. You can do mesh deformations in the sense where you can like make a static image look like it's like alive and like following your eyes and stuff. There's plenty of examples like that. I can't think of one from the top of my head now. Okay, if there are no additional questions, then cool. Thank you for joining, and yeah, feel free to reach out and let us know if you have games that you're making. Actually, I'm gonna pull a last minute thing out. Definitely, if you haven't checked out, we have recently made this. It's called Awesome Rive. It's just a repository with code samples. So let me share my screen. So this is a repository called Awesome Rive. It's just a collection of cool things that has been made in Rive, and it's completely supposed to be open source, community driven. If you or if you know someone has made something in Rive, please share it. It's a combination of articles, videos, samples, you know, bigger things like full-on apps, case studies. Fun thing to point out if you are a fan of Flutter, this was something I found out like while we were making this repo, is in last year's Flutter puzzle hack. So Flutter team normally has like a yearly competition. There was more than 10 winners that made use of Rive in their final versions. And 5 of those were first place winners. So if you want some inspiration for like what you can do with Rive and Flutter, maybe some of, or maybe 100% some of these are probably made in Flame as well. Go check it out. There's definitely some way more cooler examples of animations and games using Flutter and Rive than what I just showed you in this video. So if this video made you excited and you want to take a next step, definitely take a look at these. And if you have something awesome to share, make a pull request to Awesome Rive. And yeah, with that said, I think I'm going to end the stream. Oh, wait, another question. Can Rive now compete with Unity if I want to make a game and launch it on the Play Store? Interesting question. I would say the answer for that is always it's going to be, it depends. Rive isn't meant to replace Unity. That's not the purpose of the software. I would say a better approach would probably be using both Rive and Unity together. I think there's a lot that Rive can do when it comes to UI development or like menu screens that would be really difficult to implement in Unity on your own. And I think that kind of harmony would be awesome. And who knows, maybe some point in the future there will be support for Rive in Unity. That said, if you want to build a game with Flame, seeing as there is already really good support for Rive and Flame, then definitely. And I do think, you know, Flame is not on the level of Unity, and it's not supposed to be. But for an indie game or like a game you're trying to make yourself, yeah, I'd say you can create some pretty cool stuff. So yeah, thanks again for watching, and yeah, see you on Discord.